All right, you guys. So this is one of your problems that you've done already for homework and already submitted to Hernie and I, but we're showing you the video so that you just don't get this random score of 9 and don't really understand what you did wrong, but you can go back and watch it and actually like learn from your mistakes and see what you did wrong and try to keep improving. That's the goal right now. So instead of just looking things up online and figuring out how to do it to get points, like the points are not that important. It's about a growing process and learning and going back and rewatching one that you've tried on your own to see what you did wrong. So this is from the year 2006. It's the very last problem in the free response, number 6. So that means it's a non-calculator problem. And the stem of the problem is really short because it's a very algebra E problem. So this is kind of just like a wild card problem. Sometimes you have these and sometimes you don't, and it's just kind of up in the air. So it says the twice differentiable function f is defined for all real numbers and satisfies the following conditions. And there's actually 3 of them. So for our original f, we know f of 0 is equal to 2. We know f prime of 0 is equal to negative 4. And we know f double prime of 0 is equal to 3. So we know a function value at 0, the first derivative value at 0, and the second derivative value at 0. And it's only 2 parts, which is interesting. It's only part A and part B. So, Mr. Herny, because I did not look this one up, will you look up for me the points? So at the end we can go through the points. So part A says, okay, now you have this function g of x, and g of x is defined by e to the ax power plus f of x for all real numbers, where a is just representing a constant. Okay, find g prime of 0 and g double prime of 0 in terms of a. So our final answers for those are not going to be just numbers. It says in terms of a, so it's probably going to be some numbers and the variable a and an expression answer. Show the work that leads to your answers. So remember we said before, like show your work is a lot of like math. You don't have to have necessarily a lot of English, but they want to see the work. So if I want to find g prime of 0, maybe I should find g prime of x first. Find the derivative in general terms first, and then plug in that numerical value to get that instantaneous rate of change. So g prime of x would equal taking the derivative of the left-hand side, so now I'm going to take the derivative of the right-hand side. So isn't the derivative of e to the something, e to that something, but since it's not just an x here, isn't the derivative of that, its chain rule, the exponent's like the inside chain part, going to be times a. The derivative of ax, if a is just a constant, would be a. If it were 2x, it'd be 2, right? Calculus is beautiful. There's my derivative of my first term, plus, right, plus the derivative of the second term. Oh, the derivative of f of x would become f prime of x. And maybe I would rewrite that to put the constant a in front of the e to the ax power. I think a lot of you would do that just because it looks cleaner and prettier in algebra. And now I have that first derivative in general terms in terms of x. And now if the directions were telling me to find g prime of 0, I'm going to plug my 0 in. So g prime of 0 equals a times e to the a times 0. Remember replacing x with 0 plus f prime of 0. Well, 0 times a would just turn into 0. And e to the 0 power, of course, we know by definition is 1. F prime of 0, they gave as one of our 3 initial condition information pieces. And f prime of 0 is negative 4. So g prime of 0 would equal a times 1 would just be a minus 4, or a plus negative 4. So there's the first part. But remember, this one had 2 parts. So they also wanted us to find g double prime of 0. So if they want us to find g double prime of 0, then we better start by finding g double prime of x first, in general, in terms of x first, right? So we're finding the second derivative. Well, the second derivative is the derivative of the first derivative. So if I go back to this step, where I had the first derivative kind of cleaned up a little bit, that's where I'm going to be taking the derivative of both sides to lead me to my second derivative in terms of x. So I already did the derivative of the left-hand side. The a, if it's just a constant, just hangs out in front. It's the constant multiple rule. The derivative of e to the something is e to that something, e to the ax power. But the derivative of ax is not just 1, so it's really chain rule. So it'd be times a. Following? Plus the derivative of the next piece. Well, the derivative of f prime of x would be f double prime of x. So again, I could see a lot of us just cleaning this up a little bit to get that second derivative in terms of x cleaner before we substitute in the value of 0 in place of x. So a times a, any base times itself would turn into that base squared, would be a squared times e to the ax power plus f double prime of x. And now every x we see we're going to replace it with a 0 on both the left-hand side and the right-hand side. So the a squared would stay a squared. E to the a times 0 would just be e to the 0. E to the 0 by definition turns into 1. So it would just be a squared times 1, which would remain a squared. Plus f double prime of 0 was one of the things they gave us at the very beginning of the problem. F double prime of 0 was the output of 3. And we have our expression in terms of a. Remember that said it was going to be an expression for g double prime of 0 and g prime of 0 in terms of a. And both of them have an a in them. So very algebra-y. I would be thrilled to get this problem on my AP exam because it's just so algebra and not context and not words and not big theory. And this one only had a part A and a part B, so now we're on part B. So they throw us a brand new function. So last time we had g going on. This time, part B, we have h going on. So h of x equals, oh my goodness, look at this, Mr. Herney, some trig. Cosine of kx. All of that's inside the parentheses. We're taking cosine of all of that. Squashed right next to f of x. So I'm going to kind of emphasize and put a dot there to show that those are multiplied together. So non-calculator, trig, I bet we might have to do some exact values at some point, where k is representing a constant, just like a on part A of the problem was representing a constant, k on part B of the problem represents a constant. Find h prime of x, so we want to find the derivative in general in terms of x, and write an equation for the line tangent to the graph of h at x equals 0. So we'll write an equation of a tangent line by finding the point in the slope towards the end of the problem, but first we got to find the derivative in terms of x and find h prime of x. So we're going to take the derivative of both sides. So the left-hand side is the easy side. Oh my goodness, you guys, calculus is beautiful, but if you are finding a derivative of two different functions multiplied together, don't you have to bust out product rule? And if you don't do product rule, you're probably going to get nothing on this part of the problem. So the first times the derivative of the second, the derivative of f of x is just f prime of x, plus the second times the derivative of the first. So isn't the derivative of cosine, right now we're doing derivatives, cosine is a co-function, negative sine, leaving the inside unchanged, kx, times the derivative of that inside, which is k. So like we did in part A, I feel like a bunch of us would maybe want to clean it up. You don't have to. You could plug in right now. It's not really going to matter. But if you did clean things up a little bit, maybe leaving the trig stuff first, the function notation stuff second, maybe moving the constant in front with the negative sign, minus k times sine of kx, the trig stuff first, the function part second. It doesn't matter though. It's going to be the same multiplication. You can do in either order, commutative property. So whatever makes sense in your world. So now that we have that part, remember that they want an equation of a tangent line, right? And they want us to write the tangent line of the graph of h at x equals 0. So don't we need 2 points to write, or 2 things to write an equation of one? We need a point, and we need the slope. Well, I'm going to actually start with the slope because we just found h prime of x in general terms. So if we want to find the slope at the instant when x is 0, let's plug in 0. So h prime of 0 equals cosine of k times 0. Remember, k was just representing a constant that we don't know, so we got to leave it as k, times f prime of 0 minus k times sine of k times 0 times f of 0, squashing right on the end of my board. Now you guys can't even see me. So 0 times k would stay 0. Oh, we said exact values. We're on the unit circle at 0 radians. 0 radians, 0 degrees would be the order pair 1, 0. Cosine is the x value. So wouldn't this turn into 1? F prime of 0, they gave us at the original problem, was negative 4. Minus, we don't know what k is, but look at this, you guys. K times 0 is 0, and sine of 0 is 0, and it's multiplied with all the rest of this junk, so isn't this all going to go to 0 anyway? So wouldn't our slope equal just the 1 times the negative 4, which is negative 4? So I'm going to star that. I usually like to star the 2 things that I'm trying to get to eventually plug into point slope form. And now I just need the point. So we know the x value. We know our x value is 0. but we don't have the y value. So don't we find the y value by using the original h rule? So h of 0 equals cosine of k times 0 times f of 0. Well, we just did k times 0 be 0, and cosine of 0 over there on our little picture gave us the exact value of 1. And f of 0, they gave us at the beginning of the problem, was 2. And 1 times 2 would give me 2. So my point is 0, 2. And now we plug into point slope form. So y minus 2 equals the slope times the quantity x minus 0. And I would stop right there. You could add the 2 over. You don't really need to take the time to distribute. I mean, because it's x minus 0, some of you might just drop it. But honestly, I would just stop. Just stop and be done. It's non-calculator. You've done a lot of good trig stuff and exact values and a lot of like hard chain rule derivative stuff. Okay?
As far as points go, it's pretty easy. You get 1 point for g prime. You get 1 point for g prime of 0. We're going to get 1 point for g double prime. And then 1 point for g double prime of 0. Okay, so it's going to be 4 points in part A and then 5 in part B.
Woo!
Over here, you're going to get 2 points for h prime.
Which could be either version. These are equivalent. It doesn't matter where you stopped.
You're going to get 1 point for finding h of 0 to be 2. You get 1 point for finding h prime of 0 to be negative 4. And then you're going to get 1 point for your equation of the line.
Nice. All right. Hopefully you remembered product rule, or that would have been a rough one.